Okay, good afternoon, everyone. Thanks all for coming. I've just been notified that the speakers in the room aren't working, so it'll just be my voice. If you can't hear me, there are lots of seats up front as well. So good afternoon to all of you. In case you're wondering, Joe Russell, my colleague who was originally supposed to present, he wasn't able to come, so I'm standing in for him today. I'm Kevin Leong, product manager for big data at VMware and out of Palo Alto. So I actually drove up out of Palo Alto this morning, came into Sacramento, and I started at about 10 a.m., right? And I think I hit about the tail end of the morning rush hour, a lot of engineers getting into work late in the Silicon Valley area. And it was a good thing I was going in the opposite direction, right? Reverse commute, because if you're familiar with the Bay Area, the whole 880 south was kind of jammed up coming onto 237, and those vehicles were definitely not moving at all. And that kind of gave me a thought there, right? Because the title of this talk is infrastructure, and when we talk about, we've kind of appropriated that term as a computing industry, infrastructure, but it's been used for certainly a longer period of time to describe things like transportation and roads and highways and such. And as I looked at that backup, traffic backup, I thought, well, you know, it kind of sucks to be sitting in that jam, and folks, as it relates to big data, might have kind of the same thought as to, well, I'm kind of apprehensive putting big data on my infrastructure, because what if my infrastructure breaks, right? What if I get I get jams, I get oversubscribed, and the whole thing just shuts down. And I also thought, wouldn't it be great if we could magically make an extra lane or an extra highway appear, or if, you know, I was going in the other direction, and I was going at a speed limit, 4 lanes northbound, speed limit, 4 lanes southbound, completely stuck. What if we could kind of, you know, move the median and have more lanes coming south and fewer lanes going north at the appropriate times of day? And that's probably being done today at some points with bridges and tunnels and such, but it's hard to do that instantaneously with, you know, matters of civil engineering, with roads and overpasses and things like that. But that's kind of the magic of software, and that's kind of why I like working in software. You can actually do some of these things with infrastructure in software, right? Move boundaries, move partitions, and then spin up things quickly, spin down things quickly. And so that's kind of what I want to talk about today. So I want this to be kind of an educational session. Coming from VMware, we deal a lot with infrastructure-related topics. I just want to share with you kind of what we're hearing from our customers. Many of them come from the private sector, enterprises, but, you know, big data challenges are not dissimilar across private and public sector. So maybe some of these things might resonate with you, and I'll certainly be around after this to answer questions as well. So let's kind of start off. This is kind of a complicated slide here, but I did want to fast forward a little bit to the end game for big data, right? When we go talk with customers, this is what a lot of them, especially those on the data side, are thinking about. Again, the theme up there is the right big data tool for the right job. I'll be repeating this theme throughout this presentation, mostly around infrastructure. But that's really what customers want. They want to use the right tool for the right job. And it's not only Hadoop. Certainly Hadoop is front and center today, but there are a whole number of other technologies that are kind of in the big data space. So if I can maybe go through quickly, starting from the left, right? So data comes in. It's either real-time streaming data, or it's more traditional sources of data, perhaps going through some real-time processing. Traditional data tends to come through ETL potentially, and you put it all in some repository for both your structured and unstructured data. That's kind of the holy grail, right? Put it all in one place. If you're using Hadoop HDFS, MapR is another file system. They're another Hadoop vendor with their own file system and such. So you put it in one place, and then you do different types of analysis on it, depending on your need. Okay, starting from the right, it might be batch processing with Hadoop that we're familiar with. You put Hive on top of it, and then you get a query language that's familiar to a lot of analysts. As you move from the right to the left, you have more analytic type engines like Hawk, Impala, MPP databases for interactive analysis, and then real-time databases like HBase and so on. And so these are the engines that sit on top of your data, and then you can expose it to analysts through data visualization. You can do predictive modeling on it with machine learning, build models, and act upon new inputs and make decisions immediately based on those models. And yeah, this is really where customers that I talk to want to get. Let's double click a bit more in the infrastructure space, right? I've described a lot about what the data engines are that live in this big data world. If I double click into the infrastructure piece, like I said, it's not only about Hadoop. Now, it's great if you could have infrastructure for Hadoop. You don't want to think, what I'm trying to say here is you don't want to think about just one Hadoop cluster in isolation, because before long, you'll have to start thinking about putting other things next to Hadoop, or you'll have to start thinking about multiple Hadoop clusters. So what are some considerations that you want to have in your mind as you think of an infrastructure for big data generally, right? So the point here is it's not only Hadoop, love all, serve all. That's something I picked up from Hard Rock Cafe, right? So what we really like is some sort of distributed OS that does resource management, some sort of distributed file system that actually is scalable enough that it can accommodate Hadoop and all its other complementary big data analytic engines like HBase, SQL and Hadoop, NoSQL, and other things. So that's kind of the main thrust of my talk today. This is where I want to get to. But first, it's going to take some effort, I think, to get from zero, or getting from where we are today to this vision. So as we talk with our customers, we find that people fall along various points in the Hadoop or big data continuum. The way I describe, the way we like to classify our customers are, well, in terms of scale, right? How many nodes you have, starting from 0 to the 10s to the 100s potentially, and then how integrated your big data clusters are. So if you're just starting out, you'd probably just have a standalone cluster that's just doing its thing, and then as you grow your clusters into production and as they become an integral part of your business, you get, kind of something like this, right? So this is kind of the end goal that we're trying to get to. So where do our customers fall? A lot of people are either, just don't really have Hadoop, they're just investigating, or they're trying it out. So here's the thought here. You're just playing around with Hadoop, right? We call it stage 1, Hadoop piloting. Often starts with a department, a line of business. They just want to figure out if Hadoop is right for them, right? Things like performance, benchmarking, that's not that important at this point. They just want to see if there's value in Hadoop for their business. Stage 1, a lot of people fall into this category. And then the stage 2, when Hadoop starts being part of your everyday business, becomes mission critical in some sense. Serving a few departments, it needs to be reliable, available, right? A couple of use cases, you grow both in scale and size of clusters, and sometimes it includes core Hadoop plus other components like SQL and Hadoop or HBase. Take it to the last step. Very few people are over here. This is Hadoop with all the bells and whistles, big data, with all the frills on it. If you're not familiar with that, that's the Mumakil from the Lord of the Rings, right? They use these big elephants to go fighting and all that. So this is what we call stage 3, the cloud analytics platform, kind of the end goal that I showed you earlier, where you have many departments, different tools, different big data tools, and ideally all sitting on the same platform. Why? Because when we talk big data, we don't really want to move that data around. We'd like for that data to kind of sit in place and attach all these tools on top of it. So that's really the Hadoop journey that we're seeing within our customer base. Most people are in kind of stage 0, stage 1, some in stage 2 today. So at this point, I have a couple of considerations for you as you think about infrastructure and architectures, things that you might want to keep in mind when deciding what works best for your big data environment. First off is operational simplicity, right? It might help to start off with what the objective is. What do Hadoop users really want? And let's describe the Hadoop user, right? They're typically called data scientists or analysts or developers. They're not typically that fluent with IT. Ideally, they just want to do their job, get the Hadoop clusters, do their job, and not have to deal too much with the deployment and provisioning and all that detail. So like I said, they're intimate with data analysis. They know a bit about the business. In your case, business is government, so they know a bit about what your department does. And they're tasked with providing actionable intelligence that impacts key metrics or whatever your department's in charge of. What do they want from IT? They want to obtain a Hadoop cluster when they want it, right? They don't necessarily want to wait months for you to get machines for Hadoop cluster, as is often the case, not throughout the entire customer base that we see. This is fairly typical. Minimize time to insight. I want to get my analysis done quickly and iterate over it quickly, right? And then I want some reasonable performance from my big data Hadoop clusters. So how does IT respond to that? So this is Nick, kind of a fictional IT director, but the amalgamation of a number of customer conversations that we've had, and what are challenges that IT faces when talking about big data clusters, when specifying big data clusters. So we've heard all this, and all this is true. Doesn't all come from the same guy, but different guys. I don't want to be the bottleneck, right, when it comes to provisioning Hadoop clusters. These IT directors, IT admins, they've got tons to do. It's not always, the lead time is not always in procuring machines. Sometimes it's, I just have a huge backlog of things to provision, things to deploy, things to administer. Second one, I need sizing flexibility, right? Especially with big data and Hadoop clusters, you ask folks, well, what size cluster do you need? They don't really know. They'll give you a number, right? They'll say 50 nodes, but you don't really know if how much of those 50 nodes they're going to use. So that's a bit of chicken and egg problem. You actually have to have a Hadoop cluster to have a good sense of what size you need it to be. So here you would probably appreciate sizing flexibility, right? So that you can try it out, test it out, see, and then grow that over time. Other things we've heard, repeatable process, right? Maybe a template for deploying Hadoop clusters. Don't really know much about Hadoop, right? There's a shortage of skilled admins potentially available. And then just the manageability issue, right? There's different departments, again, starting up their own Hadoop clusters. I don't really like the fact that Department A and Department B have Hadoop clusters springing up all over the place. So how do I bring that under my control? So if we kind of distill those concerns into some key themes that we can look to address with the infrastructure, this is kind of it, right? What can kind of solve those problems? Automation of the cluster lifecycle, something to address complexity and the shortage of Hadoop skills, and then keeping things manageable. We talked already about flexibility in sizing clusters, and maybe something to keep up with the demands of business so that you're not underneath a whole bunch of wires like that. Setting up both hardware, by the way, and software. So first one kind of addresses the automation piece, manageability piece, right? What are some things to look at in an infrastructure, in a platform for big data? Something that keeps it simple. If you could have an easy button that does all that, that would be awesome, wouldn't it? Things to consider, it's not only operational simplicity at the software layer. It's not only just deploying the software. With Hadoop, you need to think about the infrastructure layer. How am I getting my infrastructure provision, right? For each Hadoop node, you have to install the OS, make sure that networking is all set up correctly, and then start different software services on each Hadoop node, and make sure that they're all talking well together. So both infrastructure and software, and then also the initial deployment, right? You deploy Hadoop cluster on day 0 or day 1, and then you have day 2 operations, right? What if you want to reconfigure the cluster? What if you want to scale it out? So platforms that typically help you with automation and keeping it simple might be cloud, right? Either public or private clouds that are able to give you this type of simplicity. So that's one thing to consider under the operational simplicity umbrella. Next thing, we talk about flexibility, right? Sizing flexibility. When creating clusters, it would be great if we could create clusters on the same template, potentially, but each one having maybe a variable number of nodes. And if I can start with 5 nodes, and if that's not enough, today I can go to 10 nodes tomorrow really quickly. So variable number of nodes and the ability to resize quickly, and then having also a variable node size, right? So your node might not just be the size of that machine. You could potentially partition that machine into smaller pieces so that your nodes could be small, medium, large, couple of t-shirt sizes for you, something like that. What else would make things simpler for the admin when the admin deals with big data in Hadoop? Self-service big data clusters, right? Getting out of the way of the development teams and the end users. We have seen significant interest in this. IT administrators say, well, they just want to be in the business of delivering infrastructure. They want to be agnostic to the applications. So having self-service portals in front of the infrastructure can be really helpful in this regard to make life easy for the IT admin. So you might call it Hadoop as a service. That's certainly possible also in the public cloud or private cloud. And the whole idea here is to reduce the latency involved once you negate the need for IT in the process of provisioning Hadoop clusters. So that's kind of the operational simplicity piece, thinking about that, how to consider that when thinking about a big data infrastructure. The next big category is kind of the efficiency of the platform, right? How efficient your platform is. And I was just talking with Dan up front today, and I mentioned something that he found interesting, which was when we talk with customers, not only novice customers, but even experienced Hadoop customers, right? The average CPU utilization for Hadoop cluster is about 20%, which is kind of a waste. Certainly at peaks, you can burst out to use the entire cluster, but on average, about 20% of the cluster is being used. How do we get out of that kind of waste, right? So one thing I'm trying to point out here is that as your clusters start growing, as you start getting multiple clusters, you need some kind of supervision or governance of these clusters. You don't want them to sprawl. You don't want them to get into a mess. So this sign kind of speaks to that, right? So 10 is not some kind of magic number. The point here is just that as you start having multiple clusters, as you start having bigger clusters, you need to start thinking about rules and managing them and how to play nice, right? Share resources among them, as if they were kids that you have to figure out how to share a finite number of iPads with, something like that. So this is something that resonates with a lot of our customers who have started seeing multiple Hadoop clusters spring up in their organizations. So this is, consider this an example from, say, a retail company. You might have 2 departments. Department A wants to do some kind of recommendation engine, sort of when a company recommends you, something you might like to buy, and they use Hadoop maybe to come up with those recommendations. And Department B is in the business of doing ad targeting, right? When you go on their website, they might pick out a bunch of ads to advertise something relevant to you. So this is what I mean by cluster sprawl, right? First, you have production clusters, then you have test clusters, experimentation clusters, kind of doing the same thing. And then potentially, you might have similar data, kind of redundant data being spread across these clusters as well. So in this example, maybe it's a read piece of data, log files, right? Both use cases kind of require these log files, and you have essentially replicated these log files multiple times in these clusters. Okay, so the pain points here, like I mentioned, cluster sprawl, redundant data, inefficient use of resources. In what sense? Because if each individual standalone cluster can only burst out to, in effect, what you've partitioned the number of servers that you've given to that cluster. Instead of pooling all those servers together, I can only burst out to, at maximum, only what, say, the production cluster has. So now, our IT director, Nick, his job is to drive efficiencies. And so what have we heard when talking with our customers in this regard? I want to scale out, right, when the workload requires it, kind of being elastic, being bursty. And then we talk about underutilization, right? 20% utilization, fairly common. The internal customer says, I need 50 Hadoop nodes, you give it to him, and then it ends up being underutilized. Hardware is just sitting there. Sometimes they want to use Hadoop as a service, and then, of course, he has responsibility for minimizing spend. So centralizing all these Hadoop clusters under one roof helps him do that. So a more ideal situation, rather than cluster sprawl, potentially is, well, what if we had one platform which could serve multiple logical clusters? That would be great. How do we do it? What are some considerations when thinking about your platform as to how this might be achieved? First one is the issue of multi-tenancy or isolation, right? How do I have multiple tenants on my platform, but having them not affect each other in a pathological way? So you might have different types of workloads, right? A workload that tries to grab all the resources, which we call kind of Mr. Greedy, a reckless workload, nosy workloads maybe, which try to just disturb other people's work. Basically, containers are great for isolation, for multi-tenancy. What types of isolation are we talking about, right? Resource isolation. Control the greedy, noisy neighbor. How we do that is you allocate resources to each container, and the container can only expand at most to that number of resources, or there can be a minimum reservation as well. So that to maintain SLAs, that container definitely gets that amount of resources. So resource isolation, version isolation, right? We talked about different big data tools all sitting on the same platform. You can have different Hadoop versions, different Hadoop distributions even sitting on the same platform. You can have Hadoop and HBase sitting on the same platform, and that goes to kind of the version isolation there. And then security isolation as well. Containers tend to be a good way to provide these sorts of isolation. So isolation is one key aspect of how to achieve multiple logical clusters on one platform. And then the other complementary piece is scaling or elasticity or burstiness, if you will. So what you want to do is you want to share resources efficiently so that if the other cluster isn't using it, let's say you have two clusters on the same platform, and one cluster can use most or all of the resources at any point in time. And if the higher priority cluster decides it has work to do, it can kind of kick off the lower priority cluster. So this kind of goes to the point of underutilization, right? So instead of having hardware sit idle, now you have two clusters that are active at different points in time, and then they're sharing the same underlying resource. To be a bit more quantitative about it, right? Assume you have maybe 100 servers in your organization. One way to split things up is you could partition them in a hard and fast way, in a static way, and say 33 to you, 33 to you, and 33 to you. And I have three clusters there, and they all operate at peak capacity at 33 servers worth of capacity. And if I did that, if you look at kind of the middle graph there, the red one, right? I could potentially complete that job in that amount of time. But if I had pooled all my resources, if I had 100 servers that I could burst out to at any point in time, if the other workloads are not active, my red job could take the entire set of resources and complete in a small amount of time. So the result here is increased utilization, which either results in you completing your jobs faster, so there's a performance advantage, or potentially you could be shrinking your footprint as far as your server costs go, right? Maybe you need a fewer number of servers once you pool your resources together. So that's another consideration under the umbrella platform efficiencies. Which brings us back to kind of the generalized platform for big data, right? Pooling the multi-tenancy, isolation, and elasticity aspects together. This is how we get kind of the diagram that we saw earlier, kind of a single platform with multiple logical workloads sitting on top of that, all sharing in a nice manner. Okay. Kind of the third section, integration into existing environment, right? When you consider your infrastructure choices, well, do I want to rip out what I've worked on thus far, up till now? Or do I want it to play well and play nicely with what I already have in my data center? Again, these are practical considerations that we hear from the customers that we talk to in this area. They want to use the existing infrastructure, right? Not buy new hardware. Maybe there's a good reason for that. Maybe they just want to experiment with Hadoop. They don't really want to plunk down a bunch of money to buy a bunch of new machines. They're in the piloting phase. They want to do some experiments on existing hardware. Can I do that? They want to leverage the tools or maybe the processes they already have in place, right? A lot of people, actually a lot of customers we talk to, maybe they've standardized on blades and shared storage, and then they ask, well, can I use that instead of the typical scale-out commodity hardware that kind of Hadoop grew up on? And the answer is yes, and there are trade-offs to that we can talk about. But the answer is always yes, you can do that, but use the right tool for the right job. Hadoop on public cloud, sometimes it costs too much. We've certainly heard that. Data in shared storage, do I have to move it, right? My data's already sitting there. Do I have to pull it out and put it onto HDFS on local disks? And then finally, just the overarching point is low risk, right? I don't want to be stuck with a bunch of unused hardware. I don't want to make wrong decisions up front. Is there a low risk way of trying Hadoop? So it really should try to fit into your existing infrastructure as much as possible, so long as the parameters of your big data workload allow that. So here are some big data deployment options, right? So I work for VMware, but I'm happy to say that when I talk with customers, I will tell them, yeah, there are reasons why you might choose bare metal, there are reasons why you might choose public cloud, and there are questions to ask at every stage. So for instance, how can I be responsive to business needs, right? We talked about self-service, Hadoop as a service. Cloud models seem to work well for that. And then how do I increase utilization and control costs? Static boundaries are not great for that. So bare metal, cluster sprawl, that's not great. So these are how you might go through these questions and try to answer them for yourselves and figure out what makes sense. Physical, public cloud, or virtual, kind of AKA private cloud in your data center, right? So other considerations, admin burden, leveraging existing processes and tools, maintain control of data. Does my data need to be within my organization, or can it be out there? Do I have multiple clusters? That's where consolidation makes sense to bring up utilization, right? If you have one cluster, if it's running with predictable workloads and it's running beyond 20%, maybe 50% utilization, great. You can go with bare metal and physical. That will probably work for you. Do you have clusters that run 24/7? That's going to be costly in the public cloud. Do you have short-lived clusters, in which case, then it might make sense to rent public cloud? And then do you have performance-sensitive workloads? There is a bit of overhead sometimes to public cloud and virtual, but actually not a lot, not a whole lot. But how much performance do I need to squeeze out of my workload? So these are all good questions to ask. What I've kind of found is that we try to make virtual work for the vast majority of use cases out there, and we've found that customers have been fairly responsive to that. Then another decision point, another decision parameter might be the storage that underlies your big data installation, right? This is kind of a continuum of storage. You have SANs on the left, more costly, but with enterprise capabilities. And then you have local storage on the right, which is kind of Hadoop's heritage, right? It started out with local disks on commodity hardware, kind of scale out, and it takes care of its own replication, its own reliability. It's cheaper, and it gives you higher bandwidth. So is there a right decision with storage? Again, use the tool that's right for you. A lot of people, they have SANs in their environment. They don't want to necessarily invest in a whole different type of architecture, different type of hardware. So they say, okay, if I'm in stage 1, I'm going to run Hadoop on my SAN, and that's fine. You might run into you might take a performance hit as you grow bigger, but it's probably okay for like a 10 or 20 node cluster. So these are, what I mean by making the right decision at each stage of the game. And actually, this on the right-hand side, that kind of talks to some of the pros and cons of shared and local storage, right? With shared storage, you can leverage VM movement and high availability technologies. With local storage, it's lower cost and more scalable. And this is actually a combination of both. You can actually put your master nodes, which are your more important services, your single points of failure on shared storage to benefit from the enterprise features that they have, and then put the bulk of your data on local disks. So something like that, a hybrid solution, is also possible when you go about making your storage infrastructure decisions. One thing that we've actually seen quite a bit of uptake with has been scale-out NAS solutions, right? So that was kind of the middle column there with NAS, which is it's neither the most expensive or the cheapest. It's neither the most performant or the cheapest. But one thing that you do get with scale-out NAS solutions like Isilon is that they support HDFS, but they also support other protocols as well, like NFS. So you can read and write with other protocols into the same storage, and then use that exact same storage for Hadoop and a bunch of other things as well. So a lot of people are already sucking their data into NAS storage like that, and then they just attach Hadoop on top of that. So the benefits, of course, is your data is already in place oftentimes. Lowest risk, you have enterprise functionality with your enterprise Isilon storage. And then you've kind of decoupled your compute and data layers, so you can scale your compute independently from your data now, right? So instead of buying machines with both compute and data in them in the same ratio, in a fixed ratio, now you have the capability to kind of scale them independently. So again, I'm just presenting a lot of different options for you, not saying what's the right decision, but these all work in some sense for some set of parameters. They all work for big data and Hadoop. So these are things to keep in the back of the mind as you make your infrastructure decisions. So we talked about physical versus cloud versus virtual, and then storage. And this is just a grab bag of other things that you can do in terms of, I call it choose your own adventure, because when I was young, there were these books, right? Choose your own adventure books, and you can turn the page and come up with a different ending each time. So these are some things that you can certainly do with your Hadoop clusters that you have the freedom and the flexibility to do depending on what fits your needs. Choice of distribution, number of nodes, type of storage, maybe resizing and auto scaling. We talked about elasticity earlier on. Maybe have a compute-only cluster, right, which just attaches to external storage. So all these are things that you have a lot of freedom of choice in. And then choosing the right tool job, again, this is kind of a summary of everything that we've talked about. a lot of times when people think big data, they go for the overkill, right? So I have to buy the end user says he needs this much. I have to buy this amount of hardware, and well, you end up with kind of a big drill trying to drill a small hole in a wall. So it really should fit into your existing infrastructure. It'll be hard to make the case that that does. So to sum up, kind of a couple of things that I've gone through today, right? Again, not saying what is the right or wrong decision in any of these cases, just giving you what we've been hearing from customers and things to consider as you make your own big data platform and infrastructure decisions. Operational simplicity, right? The administrative burden for the admin and also the end user, how quickly can the end user get Hadoop clusters? Platform efficiency, high efficiency will tend to lead to lower costs. It's a good thing. And then integration with your existing environment. Flexibility is key. You want something that grows with you from kind of stage 1 as you go into stage 2 and stage 3, and something that a platform that kind of fits stage 1 to stage 3, where you can kind of swap out some of the underlying hardware along the way, might make sense also. So I've kind of talked a little bit about all these considerations in general. I'll just spend one slide telling you about what we've been thinking about and working on at VMware and how it meets a few of those needs, right? So we talked about we want to make a platform that fits the needs of not everyone. We can't be everything to everyone, but maybe the majority or maybe 80% of the folks, virtualization and virtualized big data might make sense. So again, this is our generalized big data platform, except that instead of kind of a generic layer there, I've said, okay, it's virtualization now. That's VMware, that's what we do. Operate clusters simply, yeah, right? Because we have put, I showed you some screenshots earlier which were captured from kind of a GUI for creating Hadoop clusters on a virtualized platform, and it's really a very simple GUI, right? You just give the cluster a name, tell it how many nodes you want, what size you want the nodes, and it sets up your cluster in virtualization, done. You don't need to get new hardware or anything like that. Sharing infrastructure efficiently, again, we said containers like VMs are a great way for sharing infrastructure, growing and shrinking both the VMs and being elastic about the number of VMs that we spin up at any point in time. If you're using resources, if you have a job, you spin up VMs. If you're not using it, you spin them down, let someone else have those resources. And then lastly, it's about architecting a scalable platform, leveraging your existing investment in VMware and maybe shared storage or blades, so you aren't going about redoing your entire process and trying to bring something that's non-standard into your data center. So that's kind of what I had. I actually think we have about 5 minutes for questions. I think we end at about 2:30. That's my email if you want further information. Our product is actually Big Data Extensions. If you want further information about it, I can help answer those as well. So I'll take questions if there are any. Okay, I'll be around, as will Dan and Nick. So if you want to stay around and chat, I'll be glad to. Thanks for attending.